Neural network does look like this web of circles and lines, and these lines were scary for me too when I looked at them for the first time. So I'm here to break it down for you in a very simple language. Even if you're not from technical background, after watching this video, you will not be intimidated by these sophisticated webs anymore. So let's begin. Let's begin with this diagram. This is called a neuron, or you can also call this a node. Here in this diagram, it is showing as circle, but you can also show it as square, you can also show it as triangle, up to you. Neuron is the most basic unit of a neural network. The job of this neuron is much like how a human brain behaves. It receives inputs, like we receive information, and then it multiplies those inputs by weights, just like we determine the importance of everything that we listen to. And after doing this, it also adds bias. Bias would be much like, suppose whatever we have heard from somebody else, we want to tell it to somebody else. Before doing that, we also add a little opinion of ourselves. So let's call this bias that opinion. The point is, neuron is not just relying on the inputs it is getting and weights it is getting. It is also adding its own bias. The result that it gets after this is called pre-activation. And the last thing the neuron does is it passes this through an activation function. Activation function is much like how human beings conclude the information. So here the neuron is deciding what to send to the next layer and what not to send to the next layer. Okay, so now first things first. Where does this input come from? Inputs are the variables that you are using when you are trying to understand your customer's behavior. Suppose Netflix is trying to understand your taste in movies so that it can suggest you better stuff. Now here the variables or the inputs would be your age, your language, the stuff you have watched in the past. So for example, if you have watched Stranger Things, then it will suggest you similar stuff like Dark maybe. Or if you have watched Friends, then it will suggest you Big Bang Theory. So the point is, whatever variables company is using to trying to understand the behavior of their consumers, those variables would be the input for a neural network. This is called an input layer. After the inputs, we saw that model multiplies these inputs by weights. But the question is, where does this weight come from? Weights is one of the parameters that model learns by trial and error. It learns it through this process called backpropagation. I'll create a different video on backpropagation. But for now, please understand it is much like trial and error. Try one number, it doesn't work, try another number as a weight. So after multiplying inputs and weights, I told you the network adds bias. But the question is, where does bias come from? Bias is also a parameter just like weights, which model learns by trial and error. And the main reason it is added that suppose all inputs for a neuron are 0 and all the weights are 0, then the neuron would be passing just zeros ahead, right? We don't want that. So you can think of bias more like a default tendency or a prior inclination, so that all its inputs and weights are 0, still the neuron can activate. The next thing is layers. Layers is more like a step. So for example, this input here is the first step of a neural network. So it is called input layer. Then this last step of a neural network is called output layer. And then in between these three layers are called hidden layers. The reason they are called hidden layers is because as a human being, we can see the input layer, we can see the output layer. But the in-between working of the neural network, the one that is happening inside the hidden layers, it is not visible to us. That is the main reason why it is called hidden layer. But the point is, all the neurons in these layers are doing the same thing. They are taking inputs, multiplying the weights, multiplying by weights, adding bias, and then passing that through an activation function. So now let's see what an activation function means. If I had to explain in simplest words what activation function means or why it is done, I would say that is done by neuron to conclude whatever output it got from here. So suppose you want to set up a rule like if the output from here is -1, then send then send 0 ahead to the next layer. Then this conclusion can be derived from activation function. This is just an example. It is much like not sending the raw output from here as it is to the next layer, but concluding it and then send it to the next layer. But if I have to explain in more technical words, I would say activation functions are used to understand complex patterns in the data. They are used to introduce non-linearity in the network. In other words, we are trying to find a line that can fit well to our data, be it this, or this. Why we are trying to find a line that fits well to our data is because this data has important information about consumer behavior. So we are trying to determine a system that can handle this data, and that is why we are trying to find a system that can fit well here. Now, which activation function you use depends on your use case. Discussing how to determine which activation function to use is out of the scope of this video, but in future I will create a video on this. But for now, I do want to give you names of some of the common ones like Sigmoid, ReLU, Softmax, or Tanh. The rule of the neural network is forward propagation. Means the data in the neural network moves layer by layer. Next thing is loss function. So remember I told you weights and biases is something that model learns by trial and error. The question is, how does it know that it has made the wrong prediction? The thing is, when we are trying to teach something to our model, we first give it few examples to learn from, and that is called training data. So when the model is learning from these examples, it starts with some random weight and bias, and then it makes certain prediction. And then it takes that predicted value and compares it with the actual value that we gave in those examples. And then it finds how far that prediction is from the actual output. This step here to find how far the model's guess is from actual output, that is done by loss function. Some of the most common loss functions are cross entropy or mean squared error. So because of this loss function, once the network knows that it has made a wrong prediction and how wrong it is, it looks back, tries to find the error, adjusts its weights, and then tries again whatever value it predicted. It compares it with the actual value in the training data. Basically, the point is, over the time, it is trying to minimize this loss function. So this process of looking back, trying to find errors, experimenting this weights, this process is called backpropagation. Congratulations, if you have come this far, then you are already ahead of most people out there. If you love this video, I'm sure you will love other videos on my channel. I make intuition first videos on complex AI concepts.